Hey there, how's it going? Good? Lovely. Okay, so in this refresher video, we're going to talk about solving equations that have polynomials as denominators, okay? So, some of them can be a little lengthy, shall I say, but the process is always the same. So let's take a look at this one. The deal is we are dealing with fractions, bottom line. And to add or subtract fractions, I don't care about multiplying and dividing them, we need a common denominator, correct? Okay, so let's do some side work over here. I have two denominators. One is x plus 5, and the other one is just x. And the deal is I need to get these two denominators to look alike. Now remember, when you change the look of a denominator, you do it by multiplying. You don't add to it, you don't subtract from it. When you change the look of a denominator, you have to multiply something to it. So if I take a look at these two denominators, and I'm like, well, I want them to look like each other, here's the question I ask myself. What do I need to multiply by the first denominator to look like the second? Now be careful, because some of you are saying, well, I need to add 5. No, you don't add 5. It's as if you had a denominator of 7 and 3. And let me rewrite the 7. The 7 is 3 plus 4, isn't it? And this is a 3. You don't add 4 to the 3 to make it look like a 7, do you? You take the 7 and you have to multiply by 3 because that's what it's missing. And to the 3 you have to multiply by 7 because it missed this 7 over here. So the common denominator is 21, right? You don't look at it like this as an addition problem. You look at it as one entity, shall I say. Well, you have to look at x plus 5 as one entity. This is completely different from x. So this denominator, just like the 7, is missing what to look like the second one? It's missing an x, just like this one was missing the 3. And then this denominator is missing the entire entity of x plus 5, just like this 3 was missing the 7. Are we good? Okay, so in this particular case, the common denominator, the lowest common denominator is x times x plus 5. Good? Okay, so now that means I need each of these denominators, and yes, even this one, because I have to do it to both. I want all 3 of these to have the same denominator. That means the first one is missing an x, so we're going to multiply by x, top and bottom. The second one was missing the x plus 5, which means I'm going to multiply the denominator by x plus 5, top and bottom. And the third one was missing both of them. So I'm going to multiply the denominator and the numerator by x and x plus 5 on number 3. Good? Okay. So let's see what this looks like. First fraction. What do you have in the numerator? 4x. And the denominator is simply made up of x times x plus 5. I'm not going to multiply them together. To be honest with you, it's a waste of my time. Cool? Okay. The second fraction, x plus 5 in the numerator, because you multiplied by 1, so it's not changing. And the denominator also has x times x plus 5. Excellent. And the fraction on the other side becomes, good, 3x times x plus 5 over, good, x times x plus 5. Great. Good job. Okay. Now all these denominators are the same, yes? And it is an equation, right? Okay, just checking because there's an equal to sign. So let me ask you this. Since all the denominators are the same, now they're the same, would it be easier if they weren't there. Because think about it, if all the denominators are the same, are they going to play any role? All the denominator tells me is what I can add together, right? Or subtract. Yes? Okay. So, what I'm going to do at this point, and I recommend you do the same, is I am going to multiply both sides by the common denominator of x times x plus 5. Because when I do that, can you see what's going to happen? Yeah, I heard some of you. You're like, cancel. You're right. This is going to get distributed to fraction 1, so that cancels. But it's also going to get distributed to fraction 2, so it cancels. Right? The one on this side, the fraction on this side, these denominators are going to cancel, which leaves us with a much simpler equation. We have 4x plus x plus 5 equals 3x times x plus 5. And now that's a much simpler equation to solve. I know in the beginning it seems like a lot of work, but first things first, get the denominators the same. Once they're the same, cancel them out by multiplying both sides by the common denominator, and you're left with a nice little equation to work with. Cool? Okay, so let's look at the next line. What do we get on the left side? Yes, you get 5x plus 5. On the right side, good, 3x squared plus 15x. Wonderful. Okay, now what? Do you know what the key is in this line? Do you know which term tells you what you're going to have to end up doing? Some of you are like, yes, I know. And some of you are like, I'm not so sure. Here's the key. You have an x squared. That x squared means you're either going to factor or use the quadratic formula. Your choice which one you're going to end up using, but that tells you that you're going to have to use one of those two methods to finish solving. But to solve it correctly, either factoring or quadratic formula, you're going to have to make certain this equation is equal to 0. Great. And me personally, I like the number in front of x squared. I like its coefficient to stay positive. So I'm going to bring everything from the left to the right, which means I'm going to subtract the 5x, and I'm going to subtract the 5 from both sides. And when I do that, on the left side, we end up with 0. On the right side, you still have 3x squared plus 10x minus 5. And now, it's your choice. Are you going to factor it? Are you going to use the quadratic formula? What are you going to do? And some of you are like, I don't remember factoring very well. Well, go look at my refresher video on factoring. That will definitely help you out. And some of you are like, I think I just want to use the quadratic formula. That's great. Either way, I'm going to see if it factors. So let me take a look. To see if it factors, I'm going to take the lead coefficient times the constant. So 3 times negative 5, which is negative 15. And I'm going to find all the combinations that multiply to negative 15. I'm giving you a quick refresher on this. That's 1 times negative 15. That's negative 1 times positive 15. That's 3 times negative 5 and negative 3 times 5. And that's it. Those are the only combinations that multiply to a negative 15. But do any of these, when you add them together, if I add this combination together, do I get positive 10? Nope, that one's out. If I add these, nope, don't get positive 10. Nope, don't get, nope. So this one isn't going to factor, which means we're going to have to use the quadratic formula. Okay. Side work. Side work is so important. And literally I say side work because I see my problem, but I'm not going to do this work right under it and confuse myself. I want to keep my problem nice and clean. So I'm going to have to use the quadratic formula. And if you're like, I don't remember it, well, gratefully I do. So I remember it as the opposite of b plus or minus b squared, or the square root of b squared. And under that is b squared, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so in this case, and remember it's in order, a, b, c. So I've got a negative 10 plus or minus the square root of 10 squared minus 4 times 3 times negative 5 all over 2 times 3. Okay, we got work to do. Okay, under the square root, we have 100, right? This is going to be positive because of these two negatives. So 4 times 3, 12 times 5, 60, all over 6, which means I end up with x equaling negative 10 plus or minus the square root of 160 all over 6. It's not asking me for a decimal, so don't go there. Stay off the calculator. You're like, no! And I'm like, yes, because if it doesn't ask me for a decimal, it does me no good to get on the calculator. So now, you have to decide if 160 is a perfect square. What do you think? Yeah, it's not. You're right. Which means I have to find the square root of 160. Wow, you got a lot of refresher in this video because we got a lot of different things happening. You kind of got a quick crash course on factoring, and then you kind of got a quick crash course on using the quadratic formula, and now you've got to figure out how you find the square root of 160. Okay, so let's do that. And I'll finish erasing that guy later. Okay. So 160 breaks down to 10 times 16. 16 is 4 times 4. Remember, square root is 2 of a kind. I got 2 4s. 2 and 5. Nope. So the square root of 160 is equal to 4 times the square root of 10. Okay, so we have x equals negative 10 plus and minus 4 times the square root of 10 all over 6. Looks like I have 2 answers. Okay, back to this guy. You're like, wait, it's a fraction. Don't you have to check to see if it reduces? You're absolutely right. So, x equals negative 10 plus 4 square root of 10 over 6. And x equals negative 10 minus 4 square root of 10 over 6. And here's what I'm noticing. It doesn't matter which one I work with because it's going to reduce the same. What I'm noticing is the numerator, I can factor out a 2. So when I factor out a 2, that's what remains, yes? Negative 5 plus 2 root 10 all over 6. This reduces to a 3. So I have x equals negative 5 plus 2 square root of 10 over 3, and x equals negative 5 minus 2 square root of 10 over 3. Agreed? Yeah, there was a lot going on in that particular problem. Let me recap. you had an equation with polynomials in the denominator. First, you got the LCD. Then you made sure every fraction had the common denominator and you changed the numerators accordingly. And then you got rid of the denominators because they were all the same, so you multiplied through and got rid of it and dealt with this nice little equation. And then we simplified the left side. Notice there was a square, which told me factor or quadratic formula. So as soon as I got everything set equal to 0, I noticed it didn't factor. So I had to use the quadratic formula, and here's your refresher on using it. I ended up with 2 answers, but remember they reduce because I could factor out a 2 and cancel it with the denominator. So here are my 2 answers. -5 plus 2 root 10 over 3 and -5 minus 2 root 10 over 3. Cool? Oh yeah, by the way, you have to make sure your answers don't make the denominator a 0. And if you look, if x is -5, that'll make the denominator 0. Or if x equals 0, that would make it a 0, which means I couldn't use those 2 numbers. Yeah, neither one of these are a 5 or a 0. Good? Okay, so I've got some examples coming your way. Take your time with them, work them out slowly, and then go find my video, my solution video on solving them, and I'll catch you on the flip side.